Today I'm going to talk about a little bit how to use Simulink, what Simulink is, and how to go about using it. So first of all, Simulink is a modeling program built within Matlab that allows for users to create block diagrams and create control systems, and then interfaces really well with Matlab. But for today, we're just going to be creating a simple control system that's going to be able to respond to a step function. So first of all, opening Simulink, you can either open it by typing Simulink into the command window, or just double clicking on this icon that says Simulink up here. It will open up in this Simulink start page. There's a lot of libraries to choose from. You can see all of my saved and recent libraries of my recent projects over here, but I'm just going to open up a blank model for now. This model has nothing on it, and what you can do is you can access items in either one of two ways: to put them on the browser or to put them in your diagram. First is opening this library, and second is just by double clicking on the main page and inputting something into the search button. So we're going to just do the latter because I know exactly what I'm going to look at. And what we're going to do right now is we're going to first create a source, which is going to be our step function. And as you can see, as we type in ST, we get a step under Simulink sources. That's here. And we can modify the time and modify different attributes by double clicking. And this is just going to be a step source. And then next we want to have, that's our input / our source. And then we want to have an output as well. And our output is we're just going to show everything. And for that, what we want to use is a scope. And the scope, you can change the amount of input ports. So we're going to have two input ports. The first input port is going to be for the step directly. And the second, because that's going to show basically how the system responds directly to the step. And our system is going to be in here. What we're going to do to respond to the system is we're going to get a controller, first of all. And in this case, we're going to use a PID controller. And you can see easily that these arrows automatically connect to the controller. And then we're also going to get a plant, which is going to take the shape of a transfer function. And these easily connect. And what we have right now is going to be a simple open loop system in which you have a step and you have a transfer function that's going to, you have a step and you have a controller and a plant that are going to attempt to respond to that. So we can rename these by clicking on them and either renaming them or confirming the name by just going under them like that. And now if you open up the scope, nothing happens. But what we need to do first is we need to run the simulation. And then you can see that we have our step here and our response, our first order response to the plant over here. So using the tools, we can, and in view, we can do a legend and show which one is which. So right now you see this is quite a bad response. The plant just increases linearly. We can change this pretty easily. If we want it to be a higher order, we can go in here and change the denominator. For example, 1, 2, 3. Because of this, because of this. And you'll see this makes it a higher order, and you can run it again, and this will automatically update. But it's still an open loop system. To get feedback into the system, what we can do is simply bring these out a little bit and close the loop. And we can do this by adding a subtractor. So if we go sum in operations, and then put that in over here, we can keep the thing that connects the PID controller to the step and ensure that it connects to the sum properly. We want that out there. But right now, there's going to be a positive feedback loop, and we want it to adjust negatively. So double clicking on that is going to give us a subtractor instead of an adder. And then connecting that arrow back here is going to give us our negative feedback loop. And once we run that, you'll see that the system adjusts a lot faster and a lot more accurately to this. We can extend the amount of time that this takes so that we can zoom out by going in here. But what we want to try to do is making this even faster. And the best way to do that is to go into the PID controller and to use its automatic tuning feature to help us with that. So right now we can go into the main section and go tune. And that will linearize its plan so that we get the appropriate and change these numbers here away from the default 110 to what we want them to be. And you'll see this is the response that it had before, and which is the dotted line. And the tuned response will be the new thing using these different controller parameters. Okay, and if we go results and update block, then the block will update. You can see that in here, the blocks have updated to the parameters that the tuner has chosen for us. And if we run it all again, we'll see that the response to the step is a lot faster.